Okay, we have a capacitor, it's charged. We connect it with a piece of nichrome wire. Okay, so here's your wire. There's a resistance in the wire, and I'll just indicate that by the symbol for resistor. But the resistance is constant through the wire, the resistivity of the wire, and the wire being uniform. So what's going to happen is, first of all, well, within the capacitor, and you don't need this to answer the question, but you have an electric field. Okay? And that electric field, multiplied by the separation of the plates, if you're talking about a parallel plate capacitor, gives you the voltage. So you get your charge distribution applies an electric field between the plates, which implies a voltage. A potential difference between the plates. Potential difference gives you an electric field in the wire. By definition, potential difference. Potential difference is your change of energy per unit charge. If you have more energy per unit charge here than you have here, then you have more energy per unit charge at the wire here than you do here. And the energy per unit charge, well, if you have a charge, well, I don't want to talk about an individual charge here because that would give you the idea of a charge that actually travels through here. And as we've talked about, you have a slow drift of charge, okay? But anyhow, whatever charge in a small unit of time moves from one plate toward the other, the electric field and the electric field in the wire is such that the potential difference has to be the same as from here to here as it does from here to here. So you get an electric field in the wire, okay? And again, we're assuming a uniform wire, so it'd be a uniform electric field. That implies a drift of charge because you have charges distributed uniformly, free charges, charges that are free to move, to drift uniformly throughout the wire. You have an electric field that's uniform through the wire, and the result is that between collisions between your charge carriers, and in a metallic conductor, that's what you have. You have a lot of collisions between the electrons. In that small time between collisions, these things pick up a little bit of velocity, or they lose a little bit of velocity in the opposite direction. They have a change in velocity that's in the direction dictated by the field and the charge. Okay? So you have a drift of charge, generally a slow drift, just fractions of a millimeter to a couple of millimeters per second in typical wires. Okay? So we have that. So now, the question is, what happens over time?